Hi everyone, in this video we'll discuss insertion sort. Now insertion sort is one of the most popular sorting algorithms and we will go over the algorithm in this particular video and we'll also study an example. So what is a sorting algorithm? What does it do? What it does is it takes a sequence of numbers as input and the output is a permutation or reordering of the same set of numbers such that they follow the sorted order. So to write it mathematically, the way we could express it is we have a sequence of n numbers, a1, a2, all the way up to an. That is your input. The output is a permutation or reordering, which is a1 prime, a2 prime, all the way up to an prime, of the same input sequence, a1 to an. So a1 prime is not equal to a1, it's one of those numbers between a1 to an. And the same holds for all the other numbers as well. So you have a reordering such that a1 prime is less than equal to a2 prime, less than equal to a3 prime, all the way less than equal to an prime. So this is one sorted order. Okay. So now let's study insertion sorts algorithm. So what I have here is that I've written the algorithm, entire algorithm here, and I'll go through this with an example. So we are going to take 6 numbers and apply insertion sort and see how to sort those these 6 numbers here. So what insertion sort does is it takes the array A, which has those numbers that you want to sort, as input. Okay. Then you are going to make multiple passes through this array. So initially, you're going to go from j equals 2 all the way up to a dot length. That is what you are going to do. That is the outer loop here. That is the for loop that is here, okay, in line 1. Now, we will go through this pseudocode here just to have a good understanding of the way different variables that are in play. But then when we'll do the example, the pseudocode will become much clearer. Now, what we have is we're going to take the ajth value and store it in key. So if say j is 3 in a particular iteration of the for loop, key will be a3. Okay, that is what we are going to store in the key. Now, what does insertion sort try to achieve? Now, when you are looking at aj, what you already have is all elements from a1 to aj minus 1. They are already in sorted order. Okay, so initially you have a1, which is already in sorted order. That is the reason the loop starts from j equals 2. Okay, so when you consider a single element, that element is already in sorted order. You don't need to sort it. That is why we are going to go from j equals 2 all the way up to j equals a dot length. Now, when we consider a particular aj, say aj is 5. Okay, that is what is happening when the j is in the j equals 5. Now, all elements from a1 to a4 are already sorted. Those 4 items have been sorted. Now you're going to take a5 and place it such that a1 to a5 now get sorted. That is what you are trying to achieve here. Okay, so that's line number 3 is actually a comment. Now, what are you going to do? We are going to initialize a new variable I that is equal to j minus 1. So wherever j is pointing to, say j is 5, you have an I which is one step behind it, okay, which is j minus 1. That's where I is. Now you are going to constantly decrement I, okay. So this while loop in line 5 is going to run all the way till I is greater than 0. Okay, that is the first condition. And AI is greater than key. We'll get to that in a second. Now, if that is true, what you will do, if this condition, the entire condition of this while loop holds, which are these 2 conditions, you're going to take the current value of AI and assign it to AI plus 1. So if say AI, I is 4, okay? So you're going to take whatever value is in AI, that is A4, and copy that over to A5, because I plus 1 is 5, okay? And then you're going to decrement I, okay? That's what this while loop does. So, and after you come out of that while loop, what you're going to do is you're going to take the value of key which you had stored in line 2, and you're going to copy that over to I plus 1. That this line 8 executes after the while loop. Note that it's not part of the while loop. Now, at this stage, you have no clue how the algorithm works. Okay, and I have not gone over the details of the algorithm so that you know how it works. I just gave you some quick overview of the different elements of this piece of code. Okay, so let's try to understand this algorithm with an example here. Okay, so in the first step, let us consider that this is your array of elements. So there is 5, 2, 4, 6, 1, and 3. That is your array A. Now, initially, you see line 1, J starts from 2 itself. Okay, so let's just take another color, say blue, and mark J. So this is where J at this point is. Okay. Now, what you're going to do, or what the algorithm is going to do, is it is going to store AJ in key. That is what it is going to do. Okay. So it is going to take 2, and that is what is stored in key. So key is going to be 2. Now, you're now going to look at I. So let's look at I here. So this is I. I will be J minus 1. And this is essentially J. Okay. Now, while I is greater than 0 and AI is greater than key. Okay. So I is greater than 0. So this array is starting from 1 to n. If you're implementing in a particular language where the index grows from 0, you have to modify this pseudocode accordingly. But here, I'm considering that the array starts from 1 and ends at n. So line 5 is going to execute till I is greater than 0 and AI is greater than key. Okay. So here AI is 5 and that is greater than key. Okay. So AI is going to write AI is 5 greater than key, which is 2. So this holds true. Okay. Then what are you going to do? What is going to happen is you are going to take AI and copy that over to AI plus 1. So this is 5, that is your AI, and you're copying that to AI plus 1. So you're copying 5 here. This is what is happening. This is what is happening in line 6. And then you are going to decrement your I. So your I will essentially be here because I is now 0. And because I is now 0, you're going to exit the while loop. Okay. So what you did was you took 5 and copied that over 2. So you can see that the 2 has been erased. That is why we are storing that 2 in key. Now, when you execute line 8, AI plus 1 equals key. So what is happening is I is here, I plus 1 is going to be 1. So you are now going to do this. So this is what is going to happen. You're now going to copy 2 to AI plus 1. So AI plus 1 is this, and you're going to copy the key over here. So this is what the array would look like. Okay. So essentially what you're doing is you're trying to move the elements over in such a way that you find the correct position for 2. Okay. So this is what is happening here. So if I just want to draw it pictorially, you're moving 5 here and you will actually copy this 2 all the way over here. If you just want to look at it in a single picture, that's the picture that we should look at. Okay. So it still may not be clear. You're still confused as to what is happening. Okay. So I'm going to erase part of this picture so that we can draw right here. So I'm just going to erase these things here. Okay. Okay. So now let's look at the next step. And as we do more steps, it is going to become, the algorithm will become more clear. All the intricacies will. So we have 2 here. we have 5, and there is 4. This is how the year looks like. There is 6, there is 1, and there is 3. This is how the array looks like. Now let's look at the position of j. So this is where j is pointed, because j is now 3. Okay, and key is equal to 4. That's what your key is. Now what is I? I is pointed here. Let me use the same color, which is black for I. So I is pointed here. Okay, so I is 2. Now while I is greater than 0, we're looking at this line here again, and AI is greater than key. So AI is 5, and that is greater than key. Okay, so therefore you enter into the while loop. When you enter the while loop, you're going to copy AI to AI plus 1. So this is how the array would now look like. You have 2, you have 5, you've copied this 5 over here, then you have 6, 1, and 3. Now, and your I will actually be here. I'm just going to make it dotted. That's where your I is. Now, you're going to, I is still greater than 0. But AI, is it greater than key? The answer is no. AI is 2 and key is 4. So you're not entering into the while loop. Now you exit out of the while loop and we look at line 8. That is AI plus 1 equals key. So this is I. AI plus 1 is this value. This value here is AI plus 1. So that will get modified to 4. That's how the array would look like, because you're going to copy that, put 4 in there. Okay, so now this is how the array would look like. You have 2, 4, 5, 6, 1, and 3. So what we can understand here is, what we are doing is, we are constantly taking the key value, or which is AJ, and finding where to insert it in the sorted elements just before that. So you can see that here, everything from 2, 4, 5 is sorted. So 2, 5 was initially sorted. You found the position where 4 has to go. So 2 and 5 are initially well sorted. Here, you found the position where 4 has to go. In the next step, we'll find where 6 should be placed, and so on and so forth. Okay, so let's, if you want to like keep on just the first picture, so I'm going to erase all this here. And what we will have is, we will have 4 move here and 5 move here. That is what is happening. Okay, so now let's look at the next step. So you have 2, 4, 5, there is 6, 1, and 3. Okay, so let's look at position of J. So J is here. Now 2, 4, 5 are already sorted. Where is I? I is going to be here. Okay, so now I is greater than 0. Let's look at key value. The key is equal to 6. AI is 5. So it's not greater than key. So you're not going to enter into that while loop. So you're just going to come out of the while loop. Just not going to even enter. You're going to bypass it and come to line 8. Now AI plus 1 is actually basically AJ. It's value of 6. So you're going to copy. If you look at this, what's going to happen is you're going to take the 6 and rewrite it over that 6. So this 6 is going to get rewritten here. This is how what is going to happen here. Okay. So let's now once again erase these. So this step was fairly simple because 6 was already in its sorted position. So nothing much happens. The way to show what happened is just that 6 is here. That's what is happening. just gets copied in the same place. Now let's look at 1. Now 1 has to move all the way to the front. That is what is going to happen here. So at this stage, we have 2, 4, 5, 6, 1, and 3. Be very clear that this is where j is. Your I is initially going to be here. And you're going to compare AI with key. So your AI is 6. 6 is greater than 1 at this point. Okay. So what you're going to do is, so your AI equals 6. Key equals 1. So AI is greater than key. So you're going to take AI plus 1 and copy that over to AI. So this is how the array will look like. You will have 2, 4, 5, 6, 6, 3. Now, this is where your I will be pointed to, because it's going to decrease, and your j will be here. J will continue to be in its place. Okay. So what is going to happen in the next step? The same thing. You're going to compare AI, which is now 5, with key, which is 1, which is greater. So once again, now, so I'm just going to move this a little bit above. So now, this is how the array would look like. You will have 2, 4, you'll have 5, and you'll have another 5 here, because AI is going to get copied over to AI plus 1. Okay, 6, 3. That's how it will look like, because this gets copied over here. This copying is happening right there. So j remains here. Now I comes here. Sorry, I'll just use black. So I comes. Oops. I comes here. Okay. Now AI is going to be 4, which is still greater than key. So you're going to move this 4 here. You're going to copy that over. So the way it will look like is like this. So I'll have 2, 4, 4, 5, 6, 3. Okay. And then this is where your I will be. This is where your j will be. Okay. Now you must have understood the basic concept here. There is AI. AI is now equal to 2. It is still greater than key. So you're going to copy this 2 over here. So this logic must have become very simple, and you must be understanding it completely. So you are going to have so many colors that I'm using that I'm making these. I'm not choosing the colors correctly, but I just want to be consistent. So we have 2 here, then we'll copy this 2 over here. There's 4, 5, 6, and 3. So this is going to be j, and here is when your I is going to be. So what is going to happen is your I is now equal to 0. So it comes out of the while loop and it goes to line 8, this particular line. Okay. So what is going to happen? You're going to copy key, which is 1, right there. It's going to get copied over AI plus 1, which is this 2 here. Okay. So now this is how the array will look like. You'll have 1, 2, 4, 5, 6, 3. Just the way we wanted it. So you moved 1 all the way to the front. So now we're going to erase all this and just work on these. So I'm going to erase all this. And I'm just going to show it over here. So what's going to happen is 2 gets, everything is going to moving here, right? should start. So 6 first gets moved to 1, then 1, 5 gets moved over to the 6th position, 4 gets moved, then 2 gets moved, and finally what you have is you have 1 being copied over here. So the array would now look like this. You have 1, 2, 4, 5, 6, and then there is 3. So this is where your j will be. Okay. So now we are going to look at I, which is going to be here, and the same logic. So I'm just going to draw what is going to happen here. So first, we are going to have 6 move over here, then 5 moves over here, then 4 moves over here. Okay. And you'll have then 3 copied over here. So your array would look like this, which is 1, 2, 3, 4, 5, and 6. So our entire array will become sorted. So the thing to understand in insertion sort is you're trying to find the best place for the element that you're considering. So when you're looking at the jth element, that is aj, everything from a1 to aj minus 1 is already sorted, and you're just trying to find out the best place for aj such that everything from a1 to aj remains sorted. So that's the logic that you're going to apply. Okay, so with this you'll actually find that the entire array is sorted. Okay, so now that we've understood this example, I'm just going to erase that example, and we are now going to analyze the runtime of insertion sort, and we'll do it using the first from the ground up, and like from first principles. Okay, so let me erase this. And so it's very easy if you look at it pictorially what is happening in insertion sort, because that helps you understand how the algorithm works. Now what I'm going to do here is I'm going to calculate the runtime of insertion sort. So let me erase this too. To do that, we're going to adopt the first principles approach. So we're going to adopt, so I'm going to write cost and the number of times this line executes. So to execute line 1, let's assume that it takes C1 time. To execute 2, it takes C2 time. To execute line 3, C3, C4, C5, C6, C7, and C8. Okay, so different lines can take different amounts of time to execute. This is what we are going to do. Now, how many times does the first for loop execute? The first for loop, line 1, executes n times. This is because you have to go from j to a dot length, which is n minus 1 elements you'll look at, and then you have to come back and check the for loop again. So that's the nth time, just to make sure that you don't have to enter the for loop again. So that's n times. Line 2 executes n minus 1 times. Line 3 is a comment, so it does not execute at all. It does not have a it executes it executes, but the cost is basically 0. You don't execute comments. So now line 4, that executes n minus 1 times. Line 5, this is a little tricky. So what I'm going to do is let tj be the amount of times line 5 executes for a particular value of j. Okay, so what is tj? Tj is the number of times the while loop executes for a particular value of j. Okay, so for some j, line 5 executes tj number of times. Now, how many different values of j are there? J is going from 2 to n. So that's the total number of times line 5 is going to execute. Okay. Now line 6 executes tj minus 1 times. for a particular value of j. So for all the different values of j, it's going to execute from 2 to n. Okay. Similarly, for line 7, it executes tj minus 1 times, and you go from 2 to n. If line 5 executes tj times, line 6 and 7 are going to execute 1 less, because whenever you exit out of the while loop, you have to check the condition of the while loop again. Now line 8, it's outside the while loop, that executes n minus 1 times. Okay, so that's the total amount of times that each of these lines execute. Okay, so now let's try to write the runtime of this algorithm. So the runtime of this algorithm is Tn. Okay, so C1 is going to execute n times. The second line is going to execute n minus 1 times. The fourth line is also going to execute n minus 1 times. Okay. Now line 5 is executes tj, j running from 2 to n. So this is, so you're multiplying the cost and the number of times the line executes, because that's the total runtime, that line. So that's why we have to multiply with the c's. Now line 6 is basically j running from 2 to n, tj minus 1 plus 1, c7 is the cost for executing line 7. By cost, you might think like amount of time that is needed to execute line 7. That also is j running from 2 to n, tj minus 1. And line 8, c8 is the cost of running it, and n minus 1 is the total number of times line 8 actually executes. Okay, so now let's try to understand the runtime of this. So this is the total runtime of the algorithm. Now once we have that, we don't have to look at the algorithm per se. So let's first study the best case. When does the best case occur? So the best case is going to occur when the array is already sorted. If the array is already sorted. The array is already sorted, but you don't have to insert any element in place. So essentially, these lines inside the while loop, that is line 6 and 7, they're never executed, because you'll always find that AI is less than key, and you'll just not go inside that while loop. So 6 and 7 are never going to get executed, and line 5 is going to execute once. Okay, so here tj is going to be 1. That's the best case. So what we have is Tn is going to be C1n plus C2n minus 1 plus C4n minus 1 plus C5 summation j equals to n times 1. C6 and C7, they're going to be multiplied with 0, and that is C8n minus 1. This summation is nothing here, but it's going to evaluate to n minus 1. That's what that summation is going to evaluate to. So it's going to be a bunch of linear numbers. Okay, C4n minus 1 plus C5n minus 1 plus C8n minus 1. So it's going to be linear in n. So you can write this as an plus b, where a comma b are constants. Okay. So ultimately, the best case, Tn is a linear function of n. So when the array is sorted, insertion sort is going to take linear amount of time. Okay. So now let's consider the worst case. Okay. So now let's look at what's going to be the worst case. So worst case scenario. The worst case, what is going to be what is going to happen? It will happen this if the array is sorted in the reverse order. This is when the worst case happens. Array is sorted in reverse order. So if it's sorted in reverse order, what is going to happen? You will have, for every element that you're looking at, AJ, you'll have to basically put that in the beginning of that array. So every element has to be moved over. Okay? So TJ is essentially going to be J, because that's the number of times it has to move over. Each and every element has to move one place to the right. Okay? So if that is the case, now if what we have is summation Tj, j running from 2 to n. Okay? That is going to be j 2 to n. That is nothing but n times n plus 1 divided by 2 minus 1. Having looked at Tj, let's now look at Tj minus 1, because lines C6 and C7, line 6 and 7 have Tj minus 1. That is essentially going to be Tj minus 1 here running from this. Okay, that is going to be j equal to n j minus 1. Okay, and it's you can evaluate that similarly. Now, if we try to now plug these values, okay, what is going to happen? And I don't want to go over all the details here because it's just a little boring and tedious. So we will have something like that: C1n plus C2n minus 1 and C4n minus 1. And we'll have C5, which is n times n plus 1 by 2 minus 1. So what we are seeing here is there is going to be an n square term here. Okay, we'll have similar expressions for C6 C7 and like that. Okay, so ultimately what we will have is, because of these n square expressions, what we'll have is you will have something like this: an square plus bn plus c, where a, b and c are constants. So I didn't write the details of what will be multiplied with C6 and C7, but it's also going to be n square terms here. Okay, so the takeaway message here is Tn is a quadratic function of n. So if you want to write it in terms of the O expression, what we'll have is T of n is O of n square. That is the worst case running time is O of n square. Okay. And that gives us the bound on the runtime of this algorithm. Okay. So you can write it as you can even write it as Tn equal to theta of n square. That's a much tighter way to write the worst case runtime. Okay, so this is what we have in the worst case. With this, I'll conclude this video. So in this video, we looked at insertion sort. We studied insertion sort using an example. And then what we did was we developed the expression for the runtime of insertion sort, and we calculated the runtime from first principles, and we found that the worst case runtime of insertion sort can be written of T of theta of n square. It is also this. You can also write it as T of O of n square, but theta of n square is much tighter. Okay. With this, I'll conclude this video. Thank you for watching.